Hello, this is Algebra 1B, Part 1, Unit 2, Lesson 2, Scientific Notation. In science, we work with very, very small and very, very large quantities quite often. For example, the mass of the Earth. Okay, in kilograms. Let me look it up here. Mass of the Earth in kilograms. You can look it up too. Is 5.9736 5.9736 times 10 to the 24th kilograms. Okay? Now that's a scientific number. Okay, but we have to understand what it means. Scientists don't like to write a whole bunch of zeros. Here's what this number means in standard notation. This is 5, 9, 7, 3, 6. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 kilograms. Okay, so 1,000, million, billion, trillion, quadrillion, quintillion, sextillion, septillion, 5 septillion 973, sextillion 600 quintillion, approximately kilograms. Okay, so mass of the Earth. So let me explain basically how this works. When we count by tens, when we multiply by tens, the decimal gets moved over. Okay? So times 10 to the 24th will move the decimal 24 hops to the right. 24 places. Okay? It's moving the decimal. It's not zeros, it's decimal places. So let me give you another example. Let's say I've got a number like this. 2.9 times 10 to the 4th. Okay, what we do is we take the decimal and we move it 1, 2, 3, 4 places to the right. Now one hop gets past the 9, the next hop adds a 0, the next hop adds another 0, the next hop adds another 0. So this is 2, 9, so 1, 2, 3, 4. 29,000. Okay? All right? So that's to turn a scientific number into standard notation. Scientific and standard. Now in this case you might ask, well, why would we want to write in scientific notation when standard is so simple? You might not want to. In the case of the mass of the Earth, certainly writing 5.9736 times 10 to the 24th is a lot easier than writing all those zeros. Okay, and so for practical concerns, it is much easier to deal with some of these really large numbers. All right, mass of the Earth. Let me give you another example of a very small number, the mass of an electron. Mass of an electron. Electrons are subatomic particles with negative charge. They orbit the nucleus of an atom. Mass of electron in kilograms. Okay, here's what they say here, 9.109382. And they say E. Well, what that means is times 10 to the E stands for exponential. E negative 31. Now notice this one has a negative exponent on it. So a negative exponent moves the decimal the opposite direction. It moves it to the left. Okay, so it's going to take one hop to get past the 9, and then it's going to hop 31 times to the left. So this is equivalent to this, 0.31 let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, now it's 31, but one of them is to get past the 9, so 31. Okay, 109382. Okay, which would you rather have to write? The first, in scientific notation, 9.109382 times 10 to the negative 31st, or all those zeros? Okay, so it's definitely easier to write the mass of an electron in scientific notation. So let's do another quick example here. Let's say we have this. Let's say we have 2.9 times 10 to the negative 4th. Negative exponents mean small number. So I'm going to move the decimal 1, 2, 3, 4. 1 to get past the 2, another to add a 0, another to add a 0, another to add a 0. So this is going to be 0.01, 2, 3, 4 with the 2, right? 9. Okay, so this is scientific and this is standard. So in both cases we've converted from scientific to standard, but we also need to be able to convert from standard to scientific. So let's take a look at that here. Okay, let's say I've got this number here, 4180000, and I need to write this in scientific notation. Okay, so here's what we do. Decimal out of sight, put it on the right. If there's no decimal, it's on the right. Where does the decimal need to go? In scientific notation, the decimal always goes after the first non-zero digit, the 4. How many hops do I need to move the decimal? 1, 2, 3, 4, 5, 6 hops. Okay, now this is a big number, right? It's 4,180,000. Okay, so it's a big number, so it gets a positive exponent. So we're going to write this as 4.18 times 10 to the 6th. Okay, remember what the exponent always counts. The exponent always counts hops. How many times the decimal moved? How many times the decimal hopped? We always have the decimal in scientific notation right after the 4, right after the first digit. Only one digit followed by a decimal. Okay, so that's from standard notation to scientific. Okay, one more example. This one, a small number, 0.000000183. Okay, always take the decimal from where it is to right after the first non-zero digit. That would be right after the 1. Count the hops. 1, 2, 3, 4, 5, 6 hops. Okay, now this is a small number, so we use a negative exponent. 1.83 times 10 to the negative 6th. Again, negative 6 because it's small. It's a small number. Okay. One more thing you need to be able to do, and that is to compare scientific numbers. Okay. Let's take an example here. Let's do 3 times 10 to the 5th and 4 times 10 to the 4th. Yeah, times 10 to the 4th. Which number is bigger? Which number is smaller? Okay? Which number is bigger? Which number is smaller? Now, in order to tell, I could convert them to standard notation and compare them that way. And that's what I'm going to do first, but we'll explain shortly how to do it without converting. Decimal out of sight, put it on the right. It's right after the 3. 10 to the 5th means 5 hops to the right. So this is 3 with 1, 2, 3, 4, 5 zeros. Decimal is now right here. This is 300,000. Okay. Compare that to 4 times 10 to the 4th, decimal out of sight, put it on the right. 1, 2, 3, 4. So we're going to have a 4 followed by 4 zeros. 4, 1, 2, 3, 4. Okay, now if you compare these numbers, if you've learned to compare regular sign notation numbers, compare from right to left. Same, 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 same. Different, but different. Think of this as 0 hundred thousandths and 4 ten thousandths. So just like 300 is bigger than 40, 300,000 is bigger than 40,000. So this is bigger, and this is smaller. So in order from smallest to biggest, it's 4 times 10 to the 4th, followed by, that's smaller, followed by 3 times 10 to the 5th. Okay? Notice what went on, and this is really the key. Compare exponents first. Then compare the numbers. Okay, compare the exponents first. 5 is bigger than 4, so 3 times 10 to the 5th is bigger than 4 times 10 to the 4th. Okay, so the exponent has more to do with it than the number. Now, if the exponents are the same, then you compare the numbers. Okay, then you compare the numbers. All right, hopefully that helps.